A stone circle stands silent for thousands of years, perfectly capturing the sunrise on a single day. This video presents the startling evidence for advanced Earth knowledge in prehistoric societies. You will gain a completely new perspective on human history, one where our ancestors were master observers of the planet itself. How could a map from the 1500s depict a continent hidden under ice? What ancient device might have tracked the stars before the first metal tools? We will explore monuments that are celestial calculators, artifacts that seem to hold coded secrets, and myths that may preserve real geological events. By the end, you will see the deep past not as a simple struggle for survival, but as a time of profound discovery and forgotten wisdom. What does it mean to be an advanced civilization? The true mystery lies not in the stones themselves, but in the minds that placed them. To understand that, we must first define our terms. When we speak of advanced Earth knowledge, we are not suggesting our ancestors had satellites or quantum physics. Instead, we are recognizing a different kind of sophistication, one built upon lifetimes of meticulous observation passed down through generations. This is the deep, empirical understanding of how the world works, an intelligence rooted in the land and the sky. Think of a Neolithic community that did more than simply watch the sun rise. They tracked its slow journey along the horizon, marking its northernmost and southernmost points with towering stones. They knew when the longest day would arrive, when the nights would begin to cool, and they structured their entire ceremonial and agricultural year around this celestial clock. This is a form of advanced knowledge. It is a practical astronomy, a geophysical awareness that allowed them to predict, plan, and perhaps even navigate vast distances. It encompasses an intuitive grasp of cartography, knowing the shapes of coastlines and the paths of rivers. It includes a geological understanding, selecting specific types of stone from quarries miles away for their symbolic or structural properties. This wisdom was not written down in books. It was encoded into the landscape itself, etched onto bone artifacts, woven into the patterns of pottery, and preserved in stories told around the fire for centuries. We are searching for the fingerprints of a purposeful curiosity, a collective desire to not just live within the world, but to truly comprehend its grand, silent rhythms. That silent, patient observation of the sky found its ultimate expression in stone. Across the ancient world, from the windswept plains of England to the sun-baked islands of Malta, our ancestors began to build on a scale that still defies easy explanation. They did not construct simple shelters or defensive walls. They raised megaliths, colossal stones that seemed to speak a language of alignment and precision. Sites like Stonehenge or the Nebra temples are often called ceremonial centers, and that is true, but to stop there is to miss their greater function. These places are, in essence, monumental calendars and observatories, carved not from paper but from the very earth itself. Stand at Stonehenge just before dawn on the longest day of the year. The air is cool, the landscape quiet. Then, as the sun breaks the horizon, a brilliant shaft of light pierces the center of the circle and strikes a single, iconic stone known as the heel stone. This is not a happy accident. This alignment, repeated with the winter solstice sunset, required breathtaking foresight. The builders needed to understand the solar year, to track the sun's slow migration along the horizon, and to translate that celestial knowledge into a fixed terrestrial plan. They had to know exactly where to place tons of rock so that, for one perfect moment each year, architecture and astronomy would become one. This precision extends far beyond a single sunrise. At Nebra on Malta, a temple built over 5,000 years ago features stone doorways and altars that are precisely aligned with the equinox sunrises and the solstices. Light penetrates the inner chambers in specific patterns, marking the changing seasons with a reliability that modern clocks would envy. Archaeologists like Clive Ruggles have spent decades mapping these alignments, and their work reveals a pattern that cannot be dismissed. These are not vague orientations toward the east. They are specific, repeatable, and intentional. The staggering implication is one of sustained, generational effort. To plot the 18.6-year cycle of the Moon's extremes, as some researchers believe certain stone rows in Scotland were designed to do, requires observations passed from elder to child for longer than a single human lifetime. This represents a form of long-term data collection, a communal project to map the heavens that spanned centuries. It speaks of a society stable enough and motivated enough to invest in a project whose full purpose might not be realized for generations. The stones are the permanent record of that patient, collective watching. They are the hard drive of the Neolithic world, storing celestial data in a format meant to last for millennia. So if these stone computers could track time with such elegance, what other kinds of knowledge might they have encoded? The next clue comes from an object so small it fits in your hand, yet its purpose has puzzled historians for over a century. The transition from monumental stone to fragile parchment reveals a different kind of record. In the year 1929, during renovations of Istanbul's Topkapi Palace, a librarian made a stunning discovery. Tucked among forgotten manuscripts was a large, beautifully drawn map on gazelle skin, dated to the year 1513 and signed by the Ottoman admiral and cartographer Piri Reis. At first glance, it was a remarkable artifact of its time, showing the known coasts of Europe, Africa, and the newly discovered Americas. But a closer look sent shockwaves through the world of historical research. The map depicted the eastern coast of South America with unusual precision. More astonishingly, it seemed to show a landmass stretching from the southern tip of that continent, a landmass that bore a haunting resemblance to the coastline of Antarctica. This was the true enigma. According to modern geology, the continent of Antarctica has been locked under a mile-thick sheet of ice for at least several million years. Its true coastal outline remained completely unknown to humanity until sophisticated seismic and satellite surveys in the mid-20th century. Yet here, on a 500-year-old document, was a shape that seemed to match those modern surveys with an accuracy that defies simple coincidence. How could Piri Reis have possibly known this? The admiral himself provided a clue in the extensive notes written on the map's margins. He stated clearly that he was not the original author of this geographical knowledge. He compiled his chart from many source maps, some of which he described as being very old, dating back to the time of Alexander the Great. This admission is crucial. It suggests Piri Reis was working from a patchwork of ancient cartographic knowledge, fragments of a much older understanding of the world that had been passed down, copied, and preserved in great libraries like that of Alexandria before being scattered and lost. In the 1960s, a professor named Charles Hapgood took this idea further. He and his students conducted a detailed study, proposing that the accurate portions of the map, particularly the Antarctic coastline, must have been copied from source maps drawn in a distant antiquity, at a time when that land was free of ice. This theory, while highly controversial and disputed by many mainstream scholars, presents a profound challenge. It implies that a sophisticated, seafaring culture possessing advanced knowledge of spherical trigonometry and precise longitude measurement existed in the deep, prehistoric past. These hypothetical ancient mariners would have needed to undertake vast oceanic voyages, charting continents with an accuracy that would not be matched again until the 18th century. The Piri Reis map, therefore, is more than a curiosity. It is a ghost image, a pale copy of a lost masterpiece of human exploration. It forces us to ask a difficult question. Could the great age of discovery in the 1500s have been, in part, a rediscovery? were European sailors following faint trails blazed thousands of years earlier by forgotten navigators who already knew the shape of the world. If such maps once existed, what other instruments might they have used to find their way? This deep understanding of the Earth went far beyond marking the sky. It extended into the very ground they walked upon, into the bones of the planet itself. To construct their most enduring monuments, prehistoric builders demonstrated a geological acumen that rivals modern engineering. Consider the task they set for themselves. It was not simply about moving a large rock. It was about selecting the perfect material for a project meant to last for eternity. Think of a modern architect specifying steel for a skyscraper's frame or a special concrete for a dam. Ancient builders made similar, deliberate choices, but their material catalog was the landscape itself. At the site of Baalbek in Lebanon, a platform known as the Trilithon holds 3 limestone blocks, each weighing over 800 tons. The quarry where these monoliths were cut lies nearly a mile away. The builders did not just choose any stone from the nearest hillside. They identified a specific layer of dense, high-quality limestone, understood how to separate it from the bedrock using precise channels and wooden wedges, and then orchestrated the movement of the largest known stones ever handled by human hands. This implies a profound knowledge of local geology, of fracture lines and material strength. Similarly, the outer casing stones of the Great Pyramid at Giza were made from fine white limestone, quarried across the Nile River, while the inner chambers were built with immense blocks of granite brought from over 500 miles away. Granite is incredibly hard, difficult to shape with copper tools, yet they cut it, polished it, and fitted it with seams thinner than a credit card. This suggests they weren't just using random rocks. They possessed an applied earth science. They knew that granite could bear tremendous weight without crumbling, that certain limestones could be polished to a brilliant sheen. This knowledge likely came from generations of accumulated wisdom, centuries of trial and error passed from master quarryman to apprentice. They learned to read the land, to identify seams and faults, to understand how different stones reacted to heat, water, and pressure. They may have even chosen building sites with a mind for seismic activity, positioning massive structures in ways that helped them withstand millennia of earthquakes. Their tools may have been primitive by our standards, but their understanding of material science, born from intimate, lifelong observation of the earth, was anything but simple. This mastery over stone reveals a society in deep dialogue with its environment. But if they could move mountains, could they also move across the open ocean? The next piece of evidence suggests they not only could, but they did so with a confidence that hints at something even more startling. The mastery of stone and sea points to a mind that saw the world as a system of interconnected patterns. This same mind looked not only to the distant horizon but also deep beneath its feet, finding meaning in the darkness. To step into a place like the Lascaux Caves in France is to enter a different kind of cathedral. The air is cool and still, the silence profound. On the walls, illuminated by flickering torchlight, are the breathtaking images of bulls, horses, and deer, painted over 17,000 years ago. For decades, we saw this as the birthplace of art, a gallery of prehistoric admiration for the animal world. But what if it was also a carefully designed instrument? Some researchers, like Dr. Michael Rappingluke, have proposed a more celestial purpose. They point to specific clusters of dots painted alongside the animals, patterns that bear a striking resemblance to known star constellations like the Pleiades or Taurus. In the deep, constant dark of the cave, freed from the changing sky, these paintings could have served as a fixed star map, a permanent record of the heavens used to teach, to plan, or to conduct rituals tied to specific times of the year. This idea transforms the cave from a passive canvas into an active observatory, a place where the cosmos was brought underground and made permanent. The concept becomes even more tangible at sites like Göbekli Tepe in Turkey. While its towering T-shaped pillars capture most of the attention, the site also features carefully carved channels and depressions in the bedrock. Some archaeologists suggest these were designed to channel water or other liquids in ritualistic ways. But consider the sensory experience. In a sunken enclosure surrounded by massive pillars carved with animal spirits, a shaft of sunlight penetrating a narrow opening would have been a dramatic, controlled event. If that beam of light were to strike a specific symbol or altar only on the day of the equinox, the entire space becomes a cosmic clock. The architecture orchestrates a moment of divine theater, where the sun itself becomes an actor, illuminating the sacred on a precise schedule dictated by the Earth's orbit. This represents a breathtaking leap in understanding. It means our ancestors were not just observing the sun's path across the open sky, they were reverse engineering its geometry. They calculated how light would travel through a specific opening at a specific angle at a specific time of year, and then they sculpted their sacred space to capture that ephemeral moment. This is subterranean astronomy. It turns the cave, the most ancient of human shelters, into a calibrated instrument that connects the underworld with the heavens. The darkness was not an emptiness to be feared, but a controlled environment, a perfect screen upon which to project the predictable yet magical movements of the light. It speaks of a desire to ritualize time itself, to embed the cosmic order into the very bones of the landscape. If they could build calendars from shadow and rock, what other natural phenomena might they have sought to predict and understand? The darkness of the cave gives way to the deep blue of the Mediterranean Sea. In the year 1900, sponge divers off the coast of the Greek island of Antikythera discovered a shipwreck laden with statues and treasures. Among the corroded bronze and marble emerged a lump of encrusted gears, a mechanical puzzle that would take decades to understand. We now call it the Antikythera Mechanism. Dated to around 100 years before the Common Era, it is an astonishingly complex analog computer with precisely cut bronze gears designed to model the motions of the sun, moon, and planets, predict eclipses, and even track the cycles of athletic games. Its existence shatters our timeline for technological sophistication, but here lies a deeper, more tantalizing question. A device this refined does not appear from nowhere. It is the product of a long tradition of thought and experimentation. The genius of its geared astronomy suggests its inventors were standing on the shoulders of giants, working from principles developed over centuries, perhaps even millennia. If the Hellenistic Greeks could build a portable cosmos from bronze, could their prehistoric ancestors have built a simpler version from materials that did not survive the ages? Think of wood carefully carved with notches to track lunar phases. Imagine a bundle of marked chords or a series of aligned bones, used as a memory aid to calculate the 19-year metonic cycle that synchronizes the sun and moon. These would be the conceptual prototypes, the perishable tools that laid the intellectual groundwork for the bronze masterpiece. They would not look like technology to our modern eyes. They might resemble a ceremonial staff or a set of tally sticks. Yet in the hands of a knowledgeable elder, they could function as a computational device, encoding the rhythms of the heavens into a tangible, movable form. This idea transforms our search. We are no longer looking just for monumental stone calendars, but for the possibility of portable, personal sky knowledge. The Antikythera Mechanism, in all its intricate glory, may be the only surviving fragment of a much older and wider story of human ingenuity, a story written not in stone or metal, but in materials that returned quietly to the earth, leaving only the ghost of their function behind. The ghost of that bronze mechanism finds an echo in a German forest over 1,000 years earlier. In the year 1999, two men using metal detectors on a hill called the Mittelberg made an illegal excavation, uncovering a cache of Bronze Age weapons and a single, breathtaking object. It was a bronze disc about the size of a dinner plate, adorned with gold symbols. This is the Nebra Sky Disc, dated to around 1600 years before the Common Era, and it is now recognized as the oldest known concrete depiction of the cosmos in the world. Picture a skilled artisan working by firelight over 3,600 years ago. They are not simply decorating. With meticulous care, they are inlaying sheets of gold onto a dark blue-green bronze background that likely represented the night sky. First, a full circle of gold for the sun and a crescent for the moon. Then, a cluster of 7 small gold dots, almost certainly the Pleiades star cluster, a group of stars that has captivated human imagination across countless cultures. Scattered around them are 32 other gold stars, their patterns suggesting a specific, observed arrangement of the heavens. But the most telling additions are 2 golden arcs added later along the disk's edges. Researchers believe these represent the range of the sun's journey along the horizon between the summer and winter solstices. Later, another arc was added at the bottom, often interpreted as a solar bark, a mythical boat believed to carry the sun through the underworld at night. This layered construction tells a story of evolving knowledge. The Nebra Sky Disc was not a static piece of art. It was a working instrument, updated and refined over generations. By lining up the arcs with the horizon, a user could determine the solstices, the most critical days of the year for agricultural societies. The presence of the Pleiades is key. In many ancient cultures, this cluster's first appearance in the dawn sky, known as its heliacal rising, marked the start of the planting season or a new year. The disk, therefore, seems to be a sophisticated attempt to harmonize 2 different timekeeping systems, the lunar calendar marked by the moon's phases and the solar year defined by the sun's path. It is a physical equation, a Bronze Age calculator designed to solve the perennial problem of keeping a lunar-based ritual calendar in sync with the solar agricultural cycle. The staggering implication is one of shared understanding. The disk was found in central Germany, but the knowledge it encodes did not spring from isolation. For such a complex symbolic system to be created and understood, there must have been a standardized, widespread language of astronomy stretching across Europe. A priest in one region and an elder in another, separated by vast forests and rivers, could look at this disk and read the same celestial message. It represents a continent-wide consensus on the mechanics of the sky, achieved not through books or empires, but through oral tradition, trade, and a collective gaze fixed on the same stars. This portable cosmos transforms our view of the Bronze Age mind. It was not merely concerned with survival or local spirits. It was engaged in a coordinated, long-term project of cosmic observation, turning abstract patterns of light into tangible gold and bronze, creating a durable manual for reading the universe itself. A continent-wide consensus on the stars required a way to share that knowledge. While the Nebra Sky Disc was a portable guide, it was still a unique and precious object. For a complex system of Earth knowledge to truly endure across centuries, it needed a more widespread, durable medium. This brings us to a quiet hillside in the Balkans, where the soil holds a mystery written in clay. Here, the Vinča culture flourished between 5,500 and 4,500 years before the Common Era. They were skilled farmers and artisans, but their most perplexing legacy is not their pottery or their tools. It is the collection of over 1,000 artifacts, mostly small clay tablets, figurines, and spindle whorls, inscribed with a series of strange, recurring symbols. To an archaeologist carefully brushing the dirt from a broken tablet, the moment of discovery is charged with quiet awe. The surface is not decorated with familiar animals or people. Instead, it is covered in a grid of intricate, abstract signs, lines, angles, and branching patterns, etched with deliberate precision. These are the Vinča symbols, and they represent one of the most tantalizing puzzles in all of prehistory. At first glance, they look like nothing more than decorative marks, but their repetition across a vast geographical area and over a millennium of time suggests something far more significant. They are not random, they follow rules. Certain symbols appear together in common groupings, almost like phrases. They are found on objects used in daily life and ritual, implying they carried a shared meaning for the community. The burning question is, what did they mean? Mainstream archaeology cautiously labels them as proto-writing. This is a crucial distinction. They are likely not a full writing system capable of recording complex sentences or stories like later cuneiform or hieroglyphs. But they may represent a sophisticated system of symbolic notation. Think of it as a middle ground between a simple ownership mark and a true alphabet. Imagine a community elder needing to record a vital piece of information for the next season. Perhaps it was the ideal time for planting a certain crop, marked by the appearance of a specific star. Or maybe it was a note about a successful harvest from a particular field, or a warning about a floodline near the river. A simple drawing of a plant or a river would be a pictograph. But what if you needed to convey a more abstract idea, like the concept of a solstice, a quantity, or a direction? You might develop a standardized symbol for it. Over generations, a library of these symbols could grow, allowing for the recording of calendars, trade agreements, or ancestral lineages. Some researchers have pointed out that certain Vinča symbols bear a striking, and perhaps not coincidental, resemblance to later astronomical symbols and even letters in ancient Mediterranean scripts. Could these etchings be a forgotten route, a first attempt to fix the fluid knowledge of the sky and the land into a permanent, transmittable code? If even a fraction of this theory is correct, the implications are staggering. It would mean that a systematic method for recording complex Earth knowledge existed in southeastern Europe over 1,000 years before the rise of Sumerian city-states and their famed cuneiform. The Vinča symbols suggest a society that had moved beyond observing and building. They were on the cusp of documenting, of creating a shared external memory. Each inscribed clay tablet becomes a potential time capsule, not of gold or bronze, but of encoded insight, waiting silently in the dark earth for its language to be remembered. The transition from encoded clay to engraved stone leads us into far murkier territory. Among the most controversial artifacts ever proposed are the so-called Dropa stones. The story, which first surfaced in the mid-20th century, reads like science fiction. It claims that in 1938, a Chinese archaeologist exploring caves in the remote Bayan Ha Mountains discovered hundreds of strange stone discs, each about a foot across, with a hole in the center and a fine spiral groove running from the center to the rim. These discs were said to be extraordinarily old, perhaps 12,000 years. The most extraordinary claim followed, that microscopic hieroglyphic-like characters were found etched along those spiral grooves, telling a story of a spacecraft crash and stranded extraterrestrial beings called the Dropa. This narrative was quickly and widely dismissed by mainstream scholars, with many pointing to a lack of verifiable evidence, the discs never being produced for independent study, and the story's origins being traced to a sensationalist magazine article. It is, for all credible archaeological purposes, considered a modern myth. Yet, if we strip away the sensational alien layer, we are left with a fascinating hypothetical challenge. The very concept of such an object forces us to ask new questions about the outer limits of prehistoric possibility. Could a society 12 millennia ago have developed the technology to create perfectly circular stone discs with a precise, continuous spiral groove? If they did, what purpose could such a labor-intensive object serve beyond the decorative? The spiral is one of humanity's oldest and most universal symbols, found from Neolithic petroglyphs to the patterns of galaxies. A groove following that path could be a physical representation of a journey, a cycle, or the passage of time. Some researchers outside the mainstream have speculated, cautiously, that such a grooved disk could function as a primitive form of information storage, not unlike a phonograph record. A cord or thread following the groove while the disk is rotated could guide the user through a sequence, perhaps a ritual or a mnemonic for a complex story or calendar. Whether the Dropa stones are real or an elaborate hoax is almost beside the point for this broader inquiry. Their legend acts as a mirror, reflecting our own deep curiosity about what might be lost. They challenge the comfortable boundaries of our historical timelines, asking us to honestly assess what we believe was technologically possible in the deep past. They remind us that the absence of evidence in the archaeological record is not definitive evidence of absence. Countless objects made of wood, fiber, or painted leather have simply vanished, leaving no trace. The Dropa story, in its exaggerated way, underscores a vital truth that our understanding of prehistory is a puzzle with most of its pieces missing. We must be humble enough to admit the gaps and bold enough to wonder what might have once filled them. The boundary between sky lore and earth science blurs when we examine the materials themselves. A discovery from a much later era, yet one that whispers of a far older tradition, was made in a village near Baghdad in the 1930s. Workers excavating for a railway line unearthed a simple, unassuming clay jar, roughly the size of a man's fist, dating to the Parthian period around 2,000 years ago. Inside, however, was an arrangement that stopped archaeologists in their tracks. The jar contained a copper cylinder, sealed at the top with asphalt, and within that cylinder was an iron rod. This curious object, now known as the Baghdad Battery, presents a quiet but profound puzzle. If the jar were filled with an acidic liquid, like vinegar or fermented grape juice, a chemical reaction between the copper and the iron would generate a small but measurable electrical charge. The question is not whether it could produce electricity. Modern experiments confirm it can, but rather, what was its intended purpose? One compelling theory suggests it was used for electroplating, the process of using an electrical current to coat one metal with a thin layer of another, more precious metal. Picture an artisan's workshop in the ancient world. A small statue of copper sits in a bath of a gold salt solution. Wires, perhaps made of simple metal strips, connect the statue to one of these curious jars and the gold source to another. A faint current flows, and over time, a shimmering, uniform layer of gold begins to adorn the copper surface. This is not magic, it is applied chemistry. While the Baghdad Battery itself is not prehistoric, its existence is a beacon pointing backward in time. It represents a tangible piece of a much larger, and likely much older, body of experimental knowledge. The leap from accidentally noticing that certain acidic fruits can clean metal, to deliberately constructing a cell to harness that reaction for decoration, implies generations of observation and tinkering. This artifact forces us to reconsider the origins of some exquisite metalwork found in truly ancient sites. How did prehistoric cultures achieve such remarkably fine and consistent gilding on ceremonial objects? Could an understanding of basic electrochemical principles, born from simple, everyday materials, have been part of their craft long before it was ever formally documented? The Baghdad Battery stands as a humble but powerful testament to a different kind of ancient wisdom. It is not about aligning with the cosmos, but about manipulating the invisible forces within the Earth's own materials. It suggests our ancestors were not just passive recipients of nature's gifts, but active experimenters, learning to coax new properties from the world around them through patience, curiosity, and a hands-on genius that we are only beginning to appreciate. That same genius for encoding knowledge found its most enduring and poetic form not in stone or metal, but in story. The world's oldest known epic, inscribed on clay tablets in ancient Sumer, tells of a king named Gilgamesh and his quest for immortality. Within that grand narrative lies a chapter that echoes across continents. A wise man named Utnapishtim recounts a divine warning, a massive boat built to hold the seed of all living things, a terrifying storm that blots out the sun, and a flood that drowns the world. The description is visceral, the rain like drums, the wind like a roaring beast, the water rising to crush mountains. For over a century, scholars read this as powerful metaphor, a myth about divine punishment. But then, geology began to whisper a different possibility. In the late 1990s, marine archaeologists exploring the floor of the Black Sea made a startling discovery. They found ancient shorelines, river channels, and evidence of human habitation hundreds of feet below the current water level. The data painted a dramatic picture. Around 5,600 years before the Common Era, as the last great ice age receded, melting glaciers caused global sea levels to rise. The Mediterranean Sea, swollen with water, eventually breached a natural land barrier at what is now the Bosporus Strait. What followed was not a gentle filling, but a cataclysm. Salt water poured into the freshwater Black Sea basin with unimaginable force, a torrent 200 times greater than Niagara Falls that could have raised sea levels by as much as 6 inches per day. For the farming communities living along those fertile shores, this was not a slow change. It was a wall of water, an event of such scale and terror that it would have been seared into the collective memory of every survivor. Their world, quite literally, was washed away. Now consider the geography of storytelling. From the floodplains of Mesopotamia to the indigenous tales of the Americas, from the ancient lore of India to the epic poems of Greece, over 500 distinct cultures preserve a story of a great deluge. The details vary: a boat, a raft, a mountaintop, but the core narrative is unmistakable. This is not a case of one story spreading. It is the sound of countless voices separated by oceans and millennia, all singing the same terrifying song. What if these myths are not just allegory, but a form of ancestral data storage? In a world without writing, vital information about survival had to be woven into the fabric of memory itself. A story about a flood that covered the world is a dramatic, unforgettable way to warn your grandchildren's grandchildren. Do not build your village too close to the sea. It encodes a historical truth about rapid environmental change, a lesson about the terrifying power of rising water. These narratives become oral textbooks passed down around campfires for hundreds of generations. They preserve crucial intelligence about geology and climate, marking a profound understanding that the Earth itself is not a static stage, but a dynamic, sometimes violent, participant in the human story. The myth is the vessel, and the cargo it carries is hard-won wisdom about the very nature of the planet. Silence has a sound all its own, especially in the deep places of the Earth. Walk into a Neolithic chambered tomb, a space built not for the living but for those who came before. The air is cool and still, heavy with the weight of stone. You might expect utter quiet, but then you speak or hum a single note and the space awakens. Your voice does not simply echo, it transforms. It swells, it lingers, it seems to come from the walls themselves, creating a low, resonant drone that vibrates in your chest. This is not an accident of architecture. It is a feature, a deliberate design. The emerging field of Archaeoacoustics explores this very phenomenon, the idea that our ancestors built their sacred spaces not just to be seen, but to be heard and felt. They were master sculptors of sound. Picture a ritual held in such a place thousands of years ago. Torchlight flickers on stone carved with spirals. A group begins to chant, their voices rising and falling in a simple, repetitive rhythm. In the confined space, the sound waves bounce and combine. The individual voices blur into a single, overwhelming tone, a resonant frequency that fills the entire chamber. This sonic bath can have a profound physical effect. It can create a sense of disorientation, a feeling of vibration within the body, potentially leading to an altered state of awareness. For a culture that saw the boundary between the physical and spiritual worlds as thin, This engineered acoustics could have been a tool, a technology for transcendence, using the physics of sound to open a doorway in the mind. But the manipulation of sound may have gone even deeper than the architecture itself. Some of these ancient sites, like certain passage tombs in Ireland, are situated directly atop geological faults, places where the Earth's crust is fractured. These faults can emit low-frequency vibrations, sounds so deep the human ear cannot hear them, known as infrasound. We cannot perceive these tones consciously, but our bodies can feel them. They can induce feelings of unease, awe, or a sense of the uncanny. Whether by intuitive placement or deliberate choice, building a temple on such a spot would harness the planet's own hidden voice. The structure becomes an amplifier for the Earth's subtle hum. This represents a breathtaking level of environmental integration. It suggests an understanding that the living world was not just a visual landscape of hills and rivers, but a sonic one, a tapestry of audible and inaudible vibrations. They were listening to the planet, and they learned to build in harmony with its frequencies. This acoustic awareness points to a holistic world, where science, spirituality, and sensation were not separate categories, but intertwined threads of the same profound knowledge. The stones were not silent monuments, they were instruments, and the Earth itself was the orchestra. The stones were not silent monuments, they were instruments, and the Earth itself was the orchestra. That same intimate dialogue with the planet, that ability to listen and respond, extended far beyond sacred spaces and into the very soil that fed entire civilizations. To stand before the vast, sculpted slopes of the Andes is to witness a different kind of monument, one built not for the gods but for survival itself. Here, ancient farmers transformed entire mountainsides into a breathtaking staircase of terraced fields, each level a perfectly level shelf held back by precisely fitted stone walls. From a distance, it looks like a giant's agricultural amphitheater. This was not a haphazard clearing of land. It was a masterclass in applied earth science, a deliberate reshaping of the landscape on a scale we would now call terraforming. These builders were the original landscape architects. They understood that steep slopes meant precious topsoil would wash away with the first heavy rain. So they sculpted the land to slow that water down, creating a series of gentle steps that captured the rain, allowed it to soak in, and prevented devastating erosion. Each stone wall acted as a retaining structure, but also as a thermal mass, absorbing heat from the sun during the day and releasing it slowly at night to protect delicate crops from frost in the high altitudes. They engineered a microclimate. This required a profound, hands-on knowledge of hydrology, the movement of water. They had to predict how rain would flow down a mountainside, where to place channels to direct it, and how to build their walls to withstand the constant pressure. They selected specific crops for specific altitudes, demonstrating an early grasp of plant biology and ecology. In Mesopotamia, the challenge was different, but the ingenuity was the same. In the flat, arid plains between the Tigris and Euphrates rivers, farmers engineered vast networks of canals and ditches, a circulatory system for the land. They didn't just dig trenches, they calculated gradients, ensuring water would flow from the river to the fields by the gentle pull of gravity alone. They built sluice gates to control the flow, distributing life-giving water across thousands of acres to create the famed Fertile Crescent. This was a society-wide project demanding cooperation, planning, and a deep, generational memory of the river's seasonal floods. They were not just using the land, they were partnering with it, manipulating its fundamental processes to create stability and abundance. These projects reflect a mindset that saw the environment not as a static backdrop, but as a dynamic system to be understood and carefully guided. They possessed an intuitive ecology, a recognition that water, soil, slope, and sun were interconnected parts of a whole. Their legacy is a quiet testament to a different kind of intelligence, one measured not in gears or gold, but in the sustained fertility of a hillside for 1,000 years. They read the language of the earth, and they learn to write their response directly onto the landscape. The silent, fertile fields of Mesopotamia and the Andes give way to the restless, open sea. A different kind of knowledge was required to navigate that vast, trackless blue, a knowledge written not in soil but in the stars, the winds, and the very feel of the water beneath the hull. Settling the most remote islands on Earth demanded more than courage. It demanded a science of the ocean. Picture the scene not from a modern deck, but from the perspective of an ancient mariner. You are on a vessel of lashed reeds or carved wood, the land a memory far behind. There is no compass, no sextant, no chart in the European sense. The sky is your map. You know the rising points of key stars by heart, not as abstract points of light, but as guiding ancestors. You watch the flight patterns of seabirds, knowing certain species will fly toward land at dusk. You taste the air for the scent of vegetation carried on distant breezes, but your primary instrument is the ocean itself. You learn to read the complex patterns of swells, the long, rolling waves generated by distant storms or the steady push of major currents. A seasoned navigator could feel the subtle shift as a new swell pattern intersected with the dominant one, a tactile clue that marked the approach to an unseen island chain. This was not guesswork, it was a highly refined empirical skill, honed over generations and taught through rigorous apprenticeship. The most tangible proof of this sophisticated maritime earth knowledge comes from the Marshall Islands of the Pacific. Here, navigators created something extraordinary, the stick chart. These were not charts to be taken on a voyage. They were teaching tools constructed from flexible palm ribs and cowrie shells. The curved sticks represented the dominant swell patterns and their refraction around islands. The shells marked the islands themselves. To study a stick chart was to memorize the ocean's rhythmic grammar, to internalize how the sea behaved around land masses that might be hundreds of miles apart. It was a three-dimensional hydrodynamic map, a physical model of knowledge that was carried in the mind. This mastery allowed for the greatest migration in human history, the deliberate settlement of the Pacific. Starting from Southeast Asia, voyagers in outrigger canoes sailed into the eastern expanse, finding and populating specks of land like Hawaii, Easter Island, and New Zealand. Each successful voyage required an understanding of seasonal wind reversals, the ability to sail against the prevailing wind by tacking, and the mental fortitude to embark on a journey that might last weeks with no guarantee of finding land. The implication is staggering. This was not a haphazard drifting, but a program of intentional exploration and colonization. They were not lost, they were searching. And they succeeded because they possessed an integrated earth science that wove together astronomy, meteorology, and oceanography into a single, practical art of wayfinding. If such networks of travel existed in the vast Pacific, could similar currents of knowledge and people have crossed other oceans far earlier than our history books suggest? That mastery of the sea required a shared vision, a collective purpose that could mobilize a community toward a single, staggering goal. On a wind-swept hill in southeastern Turkey, we find the ultimate expression of that power, a discovery so profound it has forced us to rewrite the opening chapters of human civilization. Göbekli Tepe is not a city, not a fortress, and not a village. It is a series of immense circular enclosures built from limestone pillars, each one towering over twice the height of a person, carved with exquisite depictions of foxes, boars, cranes, and scorpions. The sheer scale is breathtaking, but the date is what shatters every assumption. This complex was constructed around 9,600 years before the Common Era, a full 6,000 years before Stonehenge, and 5,000 years before the first cities of Mesopotamia. The people who built this were not farmers living in settled towns. They were hunter-gatherers, communities who followed herds of animals and gathered wild plants. According to the traditional narrative of human progress, this should be impossible. Monumental architecture was supposed to be the product of agricultural surplus, of societies with spare time and specialized labor. Göbekli Tepe turns that idea on its head. Here, the temple came first. The cathedral predated the farm. Imagine the scene of its discovery, not by a grand expedition, but through the persistent curiosity of local farmers and archaeologists who noticed strange, flint-covered mounds. The first excavations revealed not simple post holes, but the tops of these massive T-shaped pillars, like stone giants buried up to their shoulders. As more earth was brushed away, the realization dawned: this was not a natural formation. It was a meticulously engineered landscape, a hill deliberately shaped and covered with structures that were, just as deliberately, filled in and buried after centuries of use. The effort involved is almost incomprehensible. The largest pillars weigh over 10 tons. They were quarried from bedrock ridges nearby, shaped with stone tools, transported up the hill, and erected into precisely arranged circles. This was not the work of a few families. It required a level of social organization, of coordinated labor and shared intention that we never attributed to nomadic peoples. They had to feed hundreds of workers coordinate tasks and pass down a complex architectural plan across generations, all without a written language or permanent settlement. What could possibly motivate such a sustained, Herculean effort? The answer may be written in the stones themselves and in the sky above them. Many of the central pillars in each enclosure are arranged in pairs, and some researchers, like the late Klaus Schmidt, who led the excavations, have noted that these pairs seem to be oriented towards specific points on the horizon. One prominent theory suggests the enclosures are aligned with the rising of certain stars, most notably Sirius, or with the cyclical movements of other celestial bodies. These spaces, adorned with powerful animal symbols, may have been ritual centers where communities gathered at key times of the year, times dictated by a sophisticated calendar woven into the architecture. The animals are not just decoration, they are a symbolic language, perhaps representing clans or constellations, anchoring mythic stories to the turning of the seasons. Göbekli Tepe presents a radical new paradigm. It suggests that the driving force behind humanity's first great leap was not the practical need for food storage, but the spiritual and intellectual need to make sense of the world. The desire to build a permanent home for the gods, to mark time with celestial precision, and to create a communal space for shared belief may have been the catalyst that eventually led to settled life and agriculture. The hill itself became a focal point, drawing scattered groups together for ceremonies, and that very gathering may have spurred the domestication of wild grains to feed the builders. This site stands as a monumental challenge to our linear view of progress. It reveals a prehistoric mind already capable of abstract symbolic thought, large-scale earth manipulation, and celestial observation on a level we are only beginning to decode. At Göbekli Tepe, the stones tell us that the human impulse to reach for the sky and to encode that reach in the land is far older and far more profound than we ever dreamed. Göbekli Tepe reveals a mind that reshaped hills to touch the heavens, but another ancient society performed a different kind of alchemy, one that worked in quiet partnership with the earth itself. Deep within the Amazon rainforest, where the soil is notoriously thin and nutrient-poor, archaeologists have uncovered something extraordinary. Scattered across the basin are isolated patches of land that defy the logic of the jungle. These are the Amazonian dark earths, known locally as Terra Preta. To stand in one of these clearings is to witness a stark contrast. On one side, the typical rainforest floor supports a dense but delicate web of life rooted in shallow, acidic earth. Step onto a patch of Terra Preta, however, and the vegetation is often even more lush and vibrant. The soil beneath your feet is not the familiar reddish clay, but a deep, rich black, crumbly and fragrant. This is no accident of nature. It is the legacy of a forgotten agricultural science, a deliberate and sophisticated act of bioengineering that began over 2,500 years ago. Analysis shows this dark earth is packed with ingredients that did not occur naturally in such concentration. It contains abundant charcoal from low-temperature burns, countless fragments of broken pottery, composted food waste, animal bones, and manure. This was not a trash heap, it was a recipe. Indigenous societies of the pre-Columbian Amazon were actively creating super soil. They understood, through generations of observation and experimentation, that charcoal or biochar acted like a sponge. It could retain vital nutrients and moisture in the root zone, preventing them from being washed away by the relentless tropical rains. The pottery shards helped aerate the soil and further improved its water-holding capacity. Together, these ingredients transformed a barren substrate into a perpetually fertile garden. This represents a profound understanding of soil chemistry and nutrient cycling. They were not just extracting from the land, they were investing in it, building its capacity for future generations. This sustainable land management allowed for the support of sizable, complex societies in an environment once thought incapable of sustaining them. The dark earth patches are more than just fertile ground. They are tangible proof of a circular economy that worked in harmony with ecological limits. These ancient farmers looked at a challenging landscape and did not see a limit. They saw a partner, and they learned the language it spoke, a language of carbon, clay, and life, writing their wisdom directly into the very ground we walk upon. The artist's hand moved by firelight, tracing the powerful curve of a horse's back on the cool, mineral canvas of the cave wall. This was not a simple sketch. The animal's coat was meticulously detailed with subtle spots, a pattern linked to a specific season. In the profound darkness of Chauvet Cave in France, preserved for over 30,000 years, we find galleries of such breathtaking artistry depicting mammoths, lions, rhinos, and herds of bison. For generations, we interpreted these masterpieces as purely spiritual, perhaps attempts to capture the essence of the hunt through magic. But a new, compelling theory is emerging from the shadows. What if these caves were not just sacred galleries, but the world's first libraries, their walls holding meticulously filed reports on the natural world? Some researchers now suggest these paintings are detailed observational records, a blend of field guide and almanac created by the keenest observers of their time. The placement of animals is not random. Different species often appear in specific chambers or along particular pathways within the cave, possibly mapping their real-world habitats. The seasonal markings on the horses, the depiction of pregnant animals, the precise rendering of antler growth stages on deer, all point to a deep, generational study of life cycles. An elder guiding a young hunter through the flickering torchlight could point to a panel of reindeer and explain, "This is how they look when they move to the valley in autumn. This is the sign that the calving season has begun." The cave becomes a communal database, a durable repository of survival-critical information transmitted through stunning visual narrative. This artistic tradition represents a profound synthesis. It is where the soul's need for beauty met the mind's need for data. The artists were master naturalists, their work a testament to a systematic, lifelong study of fauna, weather, and geography. In an Ice Age world of extreme challenge, this knowledge was their most vital tool. Their art ensured that the intricate patterns of migration, the timing of breeding seasons, and the geography of herds were not lost but celebrated and remembered. This was earth science rendered in ochre and charcoal, a testament to a mind that did not just see the animal, but understood its story within the grand, turning world. The profound artistry of the cave reveals a mind that saw the landscape as a living, interconnected story. That story was not confined to the walls of a single chamber, but was written across the entire face of the continent. Stretching between ancient hills and sacred springs, a different kind of pattern emerges, one that has captivated and puzzled researchers for a century. These are the alignments often called ley lines. The concept is simple yet staggering, the idea that our ancestors deliberately placed their monuments, burial mounds, and stone circles in precise, straight-line arrangements that can run for dozens, even hundreds of miles. Whether these alignments represent actual energy paths, as some modern theories suggest, or something far more practical, their very possibility hints at a geographical awareness of breathtaking scale. Imagine for a moment a prehistoric surveyor standing atop a prominent ridge. Their goal is not to mark a boundary for a field, but to chart a course across a vast, trackless terrain. They sight along a staff lining up a distant hilltop with a notch in the mountains far beyond. This line becomes a sacred highway, a straight track connecting places of power. Along this invisible corridor, over generations, communities build their ceremonial mounds and raise their circles, each new site reinforcing the alignment, creating a permanent map etched into the earth itself. The practical explanation is compelling. In a world without roads, a straight line is the most efficient path between 2 points. These alignments could have been trade routes, pilgrimage paths, or territorial markers, remembered and sanctified over time. Yet, there is another layer that draws the curious. Some of these long alignments seem to correspond with more than just convenience. They occasionally trace geological fault lines, follow the courses of underground water streams, or align with subtle magnetic variations in the Earth's crust. This suggests a possibility far more intriguing than simple pathfinding. It points to an intuitive form of geomancy, an ancient practice of reading the subtle energies of the land. Whether these energies were spiritual or physical, the builders may have perceived the landscape as a living body with veins of water, pulses of magnetism, and points of heightened power. Placing a temple or a stone at a specific intersection in this network was like tapping into a source, aligning human ceremony with the planet's own hidden rhythms. While the idea of mystical earth energies is often entangled with modern speculation, the core archaeological fact remains. The straight-line placement of so many sites across such vast distances could not have been accidental. It required a shared vision, a common understanding of direction and alignment that spanned entire regions. It required the ability to project a straight line across miles of undulating countryside and to pass that knowledge down for centuries. This represents a collective project of landscape mapping that transcends any single community. It implies that the sacred geography of one group was connected to the sacred geography of another, weaving separate places into a single, continent-wide tapestry of meaning. The stones and mounds become nodes in a vast, silent network, a physical internet of the ancient world, connecting people not through wires but through sight lines and shared intention. Whether these lines carried pilgrims, traded goods, or something more subtle, they stand as a testament to a mind that saw the land not as a collection of separate locations, but as a unified, resonant whole. The silent network of ley lines hints at a shared, continent-wide vision, but sometimes the most disruptive clues are not found in grand alignments, but in small, solitary objects that defy all context. These are the out-of-place artifacts often called ooparts, and they are the rogue pieces in the puzzle of history. A Roman dodecahedron is a perfect example, a hollow, 12-sided bronze object about the size of a large apple, with a circular hole in each face and knobs at each corner. Hundreds have been found across Europe, dating to the first few centuries of the Common Era. They are beautifully crafted, standardized in form, and utterly mysterious. No Roman text ever mentions them. They are not tools, weapons, or jewelry. Theories have ranged from candle holders to knitting aids to surveying instruments, but none fully satisfy the design. Their true purpose remains an open question, a quiet whisper from the past that we have not yet learned to hear. Then there are finds that push the boundaries of time even further, like the so-called Koso artifact. This was a spark plug encased in what appeared to be a 500 million-year-old geode, a story that circulated in the 1960s, while it was later identified as a modern spark plug from the 1920s encased in a concretion, not an ancient geode. The tale itself is instructive. It captures the powerful human desire to find evidence that shatters our timelines, to discover a single object that proves everything we thought we knew is wrong. The intrigue surrounding these artifacts is not necessarily about proving alien visitations or lost super-civilizations. It is about the discomfort they create. A dodecahedron does not fit neatly into our narrative of Roman engineering, which we understand through aqueducts, roads, and ballistae. It represents a niche technology, a specialized piece of knowledge that was important enough to manufacture in quantity, yet whose manual has been completely lost. This forces a humbling question: how many other specialized tools or devices made from perishable materials like wood, leather, or cord have vanished without a trace? Our view of the past is constructed almost entirely from what survives, primarily stone, pottery, and some metals. The delicate, the organic, the everyday, these are the ghosts of history. Parts, whether ultimately explainable or not, serve as vital reminders of those ghosts. They challenge the comforting linear model of technological progress, the simple idea that invention marches in a straight, predictable line from simple to complex. Human ingenuity is not like that. It is a branching tree with some limbs growing long and strong, while others are pruned back by time, disaster, or simply a change in needs. A society might develop an intricate understanding of celestial mechanics to build a calendar, yet never invent the wheel. Another might master the chemistry of concrete but not develop a written alphabet. These artifacts suggest the possibility of independent inventions, of solutions to problems we can no longer perceive, technologies that flourished in a specific cultural context and then faded when that context changed. Healthy skepticism is, of course, essential. Most parts have plausible, if elusive, explanations within known history, but the value of the anomaly is not in proving a wild theory. It is in the questions it forces us to ask. It makes us look harder at the conventional evidence, to wonder about the gaps between the stones we have found. In the end, each mysterious object is a testament to the incompleteness of the record, a single, stubborn piece that refuses to fit, urging us to keep looking, to stay curious, and to admit that the story of human knowledge is far richer and far stranger than any single timeline can contain. The stubborn mystery of a single object expands into a pattern writ large across the globe, from the deserts of Egypt to the jungles of Guatemala, and across the islands of Indonesia. We find a recurring architectural whisper: the pyramid. The form is simple, a broad base rising to a pointed apex, yet its independent emergence on continents separated by vast oceans presents one of history's most enduring puzzles. The Great Pyramid of Giza, the Temple of the Sun at Teotihuacan, and the stepped pyramids of Angkor Wat share a profound geometric kinship, yet their builders had no known way to communicate with one another. This phenomenon extends beyond architecture. Consider the symbol of the serpent, often representing wisdom, rebirth, or cosmic cycles, appearing in the myths of Aboriginal Australia, Norse legends, and Mesoamerican creation stories. Or the specific cluster of stars we call the Pleiades, whose heliacal rising marked the new year for the ancient Greeks, the Maori of New Zealand, and the indigenous tribes of North America. These are not vague resemblances, they are specific, sophisticated concepts appearing in isolated cultures. So how do we explain this? Scholars generally propose three possibilities. The first is independent invention, the idea that different human minds presented with the same fundamental challenges and observations will arrive at similar solutions. Just as multiple cultures separately discovered how to smelt copper or cultivate grain, they may have independently realized that a pyramidal shape is the most stable way to build towering structures that reach toward the heavens. The second is a common ancestral source, a much older, shared cultural root from which all these later civilizations diverged, carrying fragments of the same symbolic language and architectural principles in their migration stories. The third and most controversial is ancient transoceanic contact, the idea that seafarers in prehistory traveled far greater distances than we credit, seeding ideas across the world. The truth likely lies in a complex tapestry woven from all three threads. The pyramid form is a brilliant solution to engineering and spiritual aspirations, a meeting point of stability and ambition that many cultures could have discovered on their own. Yet the uncanny similarities in precise astronomical alignments or specific mythic narratives sometimes strain the limits of coincidence. This global resonance points to something profound about the human mind itself. When a society reaches a certain level of stability and turns its collective gaze upward, it begins to ask the same profound questions. What is our place in the cosmos? How do we measure the passage of time? How can we build a structure that will last forever and please the gods? The answers they found, drawn from observing the same sun, the same stars, and the same principles of mathematics and physics, naturally converged. Advanced Earth knowledge, in this light, appears less like a secret doctrine possessed by a few and more like a latent potential within humanity. It is the inevitable fruit of sustained curiosity, a fundamental human response to the natural world that blossoms whenever conditions allow. The separate discovery of fire is a perfect metaphor. Isolated groups understanding the need for warmth and protection, each learned to harness flame. In the same way, isolated cultures understanding the need to track seasons, honor the divine, and create legacy, each learned to harness geometry, astronomy, and narrative. The stunning parallels are not necessarily proof of a single lost civilization, but perhaps evidence of a shared human genius, a common cognitive toolkit that, when applied to the mysteries of the earth and sky, produces strikingly similar masterpieces. This shifts the question from who taught whom to a deeper inquiry into the very nature of human ingenuity and our innate drive to decode the universe. The pyramid form is a testament to a shared human genius, but the vessel for that genius was often not stone or clay, but the living human voice. For the vast majority of our history, writing did not exist. The grand libraries of the ancient world were not built from parchment but from memory. In this oral universe, the preservation of complex earth knowledge became an art form of breathtaking discipline. Picture a community gathered under a canopy of stars, the firelight dancing on attentive faces. An elder begins to speak, their voice rhythmic and measured. They are not telling a simple tale. They are reciting a lineage, a genealogy that stretches back 50 generations. Woven seamlessly into the names of ancestors and the deeds of heroes are subtle references. A drought that lasted 3 summers, a river that changed its course after a great shaking of the earth, a season when the star called the Watcher appeared in a different part of the sky. This recitation is a living database. It is a multi-layered document where history, law, and environmental science are fused into a single, memorable narrative. The accuracy of these oral archives was not left to chance. It was safeguarded by a formidable cultural technology, a system of rigorous mnemonic techniques and social structures designed for perfect fidelity. The knowledge was encoded into fixed poetic meters, set to specific melodies, or embedded within intricate dances. Certain individuals, often from childhood, were trained as the keepers of this lore. Their role was not to interpret or improvise, but to replicate, to serve as the flawless vessel for information that the entire community depended upon for its survival and identity. The most profound example of this oral earth science may be the Aboriginal Australian concept of the songline. A songline is far more than a melody, it is a sung map of the land. Each verse corresponds to a specific feature in the landscape, a waterhole, a rock formation, a mountain pass. The rhythm of the song matches the pace of walking the route. The lyrics describe the ancestral beings who created those features during the dreamtime. But crucially, these songlines also map the heavens. The paths of the ancestral beings across the land are mirrored by the paths of stars and constellations across the night sky. To know the song is to be able to navigate hundreds of miles across the arid outback, using the terrestrial features described in the verse and checking your course against the celestial map overhead. This represents a fully integrated geographical and astronomical system, a satellite navigation network held entirely in collective memory and passed on through performance. It demonstrates that advanced, practical understanding of the Earth can be sustained for millennia without a single physical record. The library is the landscape itself, and the catalogue is the song. This reliance on human memory and cultural practice forces us to redefine what we mean by a record. A written tablet can sit on a shelf for centuries, inert. An oral tradition is alive. It requires constant rehearsal, social reinforcement, and a community that values its preservation above all else. The very act of transmission, of an elder teaching a child a star chant or a planting song, becomes a ritual that binds the generations together and renews the community's contract with the knowledge itself. When that chain is broken, the loss is catastrophic, not of a document, but of an entire way of seeing and understanding the world. The silent stones we find are often just the anchor points, the physical triggers for a vast, invisible web of stories, songs, and ceremonies that once gave them meaning. They are the punctuation in a grand, spoken epic that has in most places fallen silent. That living library of song and story is a powerful testament, but it also brings us to a necessary crossroads in our exploration. For every captivating theory about lost knowledge, there stands a critical voice urging caution. Within the halls of mainstream archaeology, the reaction to claims of advanced prehistoric science is often one of measured skepticism. This perspective is not about dismissing curiosity, but about upholding a rigorous standard of evidence. Picture a conference room where two researchers debate a new interpretation of a stone circle. One, filled with enthusiasm, points to a series of precise astronomical alignments, arguing for a complex calendar. The other, a field archaeologist with decades of experience, leans forward. They acknowledge the alignments but propose a different reading. Could these stones, they ask, have primarily marked a sacred gathering place for seasonal festivals? The alignments might signal those important times, yes, but the primary purpose was social and ritual cohesion, not creating an observatory in the modern sense. This is the heart of the critical viewpoint. It applies a principle known as Occam's razor, the idea that among competing explanations, the simplest one that fits all the facts is often the most likely. For many enigmatic artifacts and sites, simpler explanations exist that do not require leaps into unknown technologies or civilizations. A carved bone with notches might be a tally stick for trading goods, not a lunar calendar. A collection of unusually shaped stones could be natural geological formations, not tools. The intricate patterns on pottery might hold clan symbolism rather than encoded star maps. The cautious scholar reminds us that we must guard against pareidolia, the human tendency to see meaningful patterns where none exist, especially when we are hoping to find them. They warn against imposing our modern, science-focused worldview onto cultures whose priorities were profoundly different. What we might interpret as a scientific instrument could have been, in its own time, a powerful religious object whose efficacy was rooted in faith and tradition, not in an understanding of physics. This critical lens is essential. It acts as a grounding wire, ensuring that our fascination does not outpace the evidence. It demands that we distinguish between a solid archaeological fact, like the solstice alignment at Stonehenge, and a speculative leap, like claiming it was a power plant or a landing beacon. This rigorous approach ultimately does not diminish the past, it enriches our respect for it. It asks us to appreciate prehistoric ingenuity on its own terms. The builders of Göbekli Tepe were not primitive astronomers trying to be modern. They were Neolithic people creating a monumental spiritual center that reflected their own cosmology, one that was likely inseparable from their daily life and understanding of the world. Their achievement is no less staggering when viewed through this lens. By seeking to understand them within their authentic cultural context, we honor the true complexity of their minds. We see them not as failed scientists, but as complete human beings whose intelligence was channeled into art, community, ritual, and a deep, practical kinship with their environment. This balanced view does not close the book on mystery, it simply ensures we are reading the right text. The critical scholar's reminder of context brings us to a humbling truth about the deep past. Our search for evidence of advanced Earth knowledge is like trying to reconstruct an entire library from a single, fireproof shelf. The vast majority of what our ancestors knew and built has simply vanished back into the earth. Think of the materials that define our own daily lives: wood, woven fibers, cured leather, painted bark. These were the primary mediums of prehistoric technology and art. A master navigator's detailed stick chart, a complex tally system of knotted cords, a finely carved wooden model of the solar system, a painted hide depicting star maps and migration routes. None of these would survive more than a few centuries in most environments. They were the books of their time, rich with data and meaning, and they were all biodegradable. What remains for us to find are the exceptions, the things made of stone, baked clay, or, in rare, precious instances, metal. The archaeological record is not a complete archive. It is a collection of the most durable scraps, the stone foundations of a library whose vast collection of wooden shelves and parchment scrolls turned to dust long ago. This inherent fragility of knowledge is compounded by the fragility of the societies that carried it. Civilizations are not immortal. A sudden change in climate can turn fertile farmlands to desert, forcing a dispersal of people and the abandonment of their ceremonial centers. A volcanic eruption can bury a culture in ash, freezing it in time but severing its living connection to the future. The rise of a new belief system or a conquering power can deliberately suppress old ways of knowing, deeming them irrelevant or heretical. Consider the Minoan civilization of ancient Crete, a sophisticated maritime culture that thrived for centuries. Their vibrant art and architecture speak of a deep connection to the sea. Yet, after a series of natural disasters and invasions, their society collapsed. With that collapse, the specific knowledge of their shipbuilding techniques, their long-distance trade routes, and their navigational secrets likely faded. Later Greek sailors might have sailed the same waters, but they did so without the detailed, accumulated charts and star lore of their Minoan predecessors. This is not a story of linear progress, but of cycles of discovery, preservation, and loss. A society can reach a peak of understanding in one area, only to have that specialized knowledge become a casualty of a changing world. The metaphor is powerful. A great library burns down. The stone pillars and the clay tablets in the basement might survive the flames, but the thousands of scrolls in the main halls, containing the true depth of the collection, are gone forever. We are left sifting through the surviving fragments, trying to guess at the scope of the wisdom that was lost. This realization should not lead to despair, but to a deeper sense of wonder. The fact that we can detect echoes of sophisticated thought in the few durable artifacts that remain hints at the incredible richness of the intellectual world that once was. It reminds us that human history is not a straight, ascending line from ignorance to enlightenment. It is a tapestry with many frayed edges and missing threads, a story where societies can forget as much as they discover. Our challenge is to look at the silent stones and the broken pottery with new eyes, understanding that they are not the whole story, but the tantalizing footnotes to a grand, vanished volume of human ingenuity. The silent stones and broken pottery are no longer the only voices from the past. A quiet revolution is unfolding in archaeology, powered by tools that allow us to see through soil, jungle, and even time itself. Modern science is providing a new lens, one that reveals hidden landscapes and decodes ancient lives with astonishing clarity. At the forefront is a technology called LiDAR, which works by firing millions of laser pulses from an aircraft. These pulses penetrate dense forest canopies, bouncing off the ground below to create a precise, three-dimensional map of the Earth's surface, stripped bare of vegetation. When researchers flew LiDAR over the jungles of Guatemala, the results were nothing short of breathtaking. The data revealed the ghostly footprints of an entire Maya civilization hidden for centuries. Where the naked eye saw only an unbroken green blanket, the lasers exposed the outlines of vast cities with pyramids, palaces, causeways, and complex irrigation systems on a scale no one had imagined. This was not a handful of lost temples, but a sophisticated, interconnected urban network, demonstrating a level of landscape management and planning that rivals modern cities. It proved that these societies possessed an advanced, practical Earth knowledge, sculpting their environment with a masterful hand to support millions of people. The technology does more than just find lost cities. It allows us to understand their relationship to the land in profound new ways. We can now trace ancient road systems that connected distant communities, follow engineered waterways that fed fields, and see how ceremonial centers were deliberately aligned with natural features like mountains or rivers, revealing a sacred geography written across the entire terrain. Beyond mapping vast landscapes, other tools delve into the microscopic world, extracting stories from the very soil. Ground-penetrating radar sends pulses into the earth, painting a picture of what lies beneath without moving a single shovelful of dirt. It can detect the foundations of buried buildings, the outlines of old palisade walls, and even ancient hearths, guiding excavations with pinpoint accuracy. But perhaps the most intimate revelations come from isotopic analysis. This technique examines the chemical fingerprints locked inside ancient bones, teeth, and plant remains. Imagine a researcher in a clean laboratory, carefully preparing a tiny sample of bone from an individual who lived thousands of years ago. By analyzing the isotopes of elements like strontium or oxygen within the tooth enamel, which forms in childhood and remains unchanged, they can reconstruct a life story. They can determine where a person was born, trace the routes they traveled during their lifetime, and even deduce major shifts in their diet. A single skeleton can tell a saga of migration, of a person who grew up in one valley, journeyed across mountains in their youth, and spent their final years in a distant coastal community. This transforms anonymous remains into individuals with biographies, revealing patterns of trade, marriage, and movement that weave separate sites into a connected social fabric. We can now see the flow of ideas and goods across continents, proving that knowledge was not stagnant but was carried, shared, and adapted along ancient highways. This scientific revolution is doing more than just adding new pages to the history book. It is actively rewriting entire chapters. It provides a check against speculation, offering hard data that can confirm a tantalizing theory or gently debunk a long-held myth. For instance, soil chemistry analysis at sites like the Amazonian dark earths has definitively shown that those fertile patches are human-made, confirming the sophisticated agro-engineering of indigenous societies. Conversely, new dating techniques might reveal that two seemingly connected monuments were built centuries apart, challenging assumptions of a single grand design. The process is dynamic and self-correcting. Each scan, each soil core, each isotopic reading adds a new piece to the puzzle, constantly refining our picture of prehistoric capabilities. We are moving from wondering what might have been to understanding with increasing precision what actually was. These tools allow us to move beyond the durable but silent artifacts, to perceive the vibrant, dynamic systems that once pulsed around them, the trade winds of commerce, the seasonal rhythms of agriculture, and the footsteps of people who viewed the world with a wisdom we are only beginning to measure. The evidence compels a quiet but profound shift in perspective. We must step back and see the entire mosaic, not just the individual tiles of stone and clay. When we view the megalithic calendars, the encoded star disks, the engineered soils, and the oral songlines as parts of a single story, a new narrative of human history begins to emerge. It is a story not of primitive struggles slowly climbing toward enlightenment, but of diverse, brilliant cultures already in deep conversation with their planet. These were societies of keen observers and innovative engineers, whose intelligence was expressed not in silicon chips, but in aligned stones and memorized constellations. They developed a holistic, integrated understanding of their world, one where practical science was inseparable from spiritual cosmology, knowing the solstice was both an agricultural deadline and a sacred moment, a point where the community, the heavens, and the earth itself were in harmony. This integrated vision is perhaps their greatest lesson to us. They did not see a division between the rational and the mystical, between exploiting the land and honoring it. Their advanced knowledge was a wisdom tailored perfectly to their environment, a sustainable partnership built on observation and respect. Recognizing this does not diminish our modern achievements, but it profoundly expands our appreciation for the vast spectrum of human ingenuity. It suggests that the drive to measure, to map, to understand the forces of nature is not a modern invention. It is a timeless, defining human trait. The quest to comprehend our place on this earth, to read its rhythms and write our stories upon it, is a thread that connects the astronomer priest at Göbekli Tepe, the navigator singing across the Pacific, and the scientist analyzing LIDAR data today. We are all part of the same enduring project, using the tools of our time to listen to the same ancient world. This journey through the silent stones and vanished songs leaves us with a profound shift in perspective. We have stood beneath the aligned megaliths, traced the lines of impossible maps, and held the fragile echoes of knowledge encoded in clay and bronze. The evidence, scattered across continents and millennia, forms a compelling mosaic. It suggests that our prehistoric ancestors were not merely surviving the wilderness, they were studying it with the focus of master naturalists, engineers, and astronomers. Their advanced Earth knowledge was not stored in books, but woven into the very fabric of their world, in the orientation of a temple, the composition of soil, and the rhythm of a navigation chant. This was a wisdom of deep connection, an empirical understanding born from lifetimes of patient observation passed from elder to child. It challenges the simplistic narrative of a linear march from primitive to advanced, revealing instead a tapestry of human ingenuity expressed in diverse and brilliant ways. These societies possessed a holistic science where tracking a star's path was as much a spiritual act as a practical one, where building a calendar from stone was an act of communion with the cosmos. While mysteries certainly remain and scholarly debates rightly continue to refine our understanding, this exploration fundamentally enriches our human story. It introduces us to ancestors who were keen observers, innovative problem solvers, and custodians of their environment. Their legacy is a testament to the timeless human drives of curiosity and adaptation. It asks us to look at a standing stone or a patterned artifact not as a relic of a simple time, but as a fragment of a sophisticated conversation between humanity and the planet. How does this change your perception of the deep past? Does it make our shared history feel more vast, more mysterious, and more intimately connected to the natural world? If this journey into forgotten wisdom has sparked your curiosity, consider subscribing for more explorations into history's greatest enigmas. And we would love to hear your perspective. What piece of evidence from our ancestors resonates most deeply with you? Share your thoughts in the comments below.